All right, Captains, let's get started today. Welcome. It is Friday. I hope you're doing all right. Once again, today's going to be our skills practice. So we're going to kind of continue to practice on what we worked on yesterday. Looking at your work, I know there is still some confusion as to how it works and what we should be able to do. So we're going to go ahead and practice that again today. I'm going to kind of teach in a different manner, see if this way helps out a little bit more. Once again, I just want to review our objective for today, which is mathematicians will be able to write multi-step expressions that represent real-world problems and justify the expression using context of the problem. So once again, to just put it in layman's terms of what we're actually doing, we're going to be able to represent a real-world problem that requires us to do more than one operation. Remember, operation is the math that we do, adding, subtracting, multiplying, dividing. So we're going to represent that as an expression that's going to represent our word problem that we are going to be reading. Very confusing, I understand, but just think of it this way. I'm going to read the word problem. I'm going to identify the operations that I'm doing. I'm going to represent that as an expression so that I can show the math that I need to do to solve the word problem. In a sense, an expression is just the math that you need to do to solve something. So I'm going to create an expression for the word problem so that I can solve it later on if I get all the numbers that I need. So that's essentially what we're doing. Keep that in mind as we're going to go through our work today. Once again, if you see me looking down, it's because I'm writing on my tablet. So if you see me look this way, it's exactly what I'm doing. So don't think I'm looking at something different. But let's get into it. So we're going to go ahead and start with this first word problem. I'm going to go ahead and read it one time. The one thing I did notice, very consistent across all the work that I looked at, is that I wasn't seeing people annotate their word problem. Go in and specifically look for these things that you see on my screen, looking for numbers to circle, underlining the question or the directions, or boxing any action words. These steps are crucial to you being able to write an expression moving forward. We need to understand the information that the word problem gives us so that then we can then figure out how to use them. The only reason we annotate word problems is to take out information that can be useful to us in solving. And these three steps are incredibly important to do so. So when I'm looking at your work today for this skills practice, I want to see you annotating your word problems because annotations are pivotal for you to be successful. The first thing I'm always going to do is just read the word problem on its own. Kathy made 2 pizzas for dinner. The first pizza had a certain number of pepperoni. Kathy decided to put 4 times the amount of pepperoni on the second pizza as she did in the first, but ate 8 slices of pepperoni as a snack before cooking it. Write an expression that represents the total number of pepperoni slices on the second pizza. Okay, so I read it one time just to have an understanding of what the word problem is about. Now I'm going to read it the second time with my intentions of annotating, of circling numbers, underlining the question, and boxing any action words. All right, so here we go. Kathy made 2 pizzas for dinner. Well, the number 2 is important. And I'm always going to include its context. What is the number talking about? 2 what? 2 pizzas. So Kathy made 2 pizzas for dinner. The first pizza had a certain number of pepperoni. Now, when we think about numbers, we know that numbers can be variables. They're just representations of numbers that we don't know yet. Certain number of pepperoni, to me, is a number. It's telling me that there's a number there I don't know. This is going to be a variable more often than not. And you'll see phrases like this, a certain number or a certain amount. Those are all considered variables. So I'm going to go ahead and circle certain number of pepperoni. And I can represent that as a variable P for pepperoni. Okay, I don't know what that number is. I know there is a number there, but I'm going to treat it as a number, which is why I circled it. Kathy decided to put 4 times. Ooh, okay, see the number 4. 4 times. When I look at that word times, that's not really a number that I want to circle, but this does tell me an action. The word times, as I look at it, tells me that I want to be multiplying something. 4 times something. Well, 4 times what? That's what we want to continue to figure out. 4 times the amount of pepperoni on the second pizza. So Kathy decided to put 4 times the amount of pepperoni on the second pizza. 4 times the amount of the first pizza on the second one. But 8 slices. So I see 8 slices there. Sorry, 8 slices of pepperoni. and she ate them. Now, more often than not, we'll see the word ate and not think of it as an action word. But if you think about that mathematically, anytime you eat something, let's say I have 5 candies on my desk right now and I ate 3. How many do I have left? That's a mathematical term in the sense of how we use it in the word problem. So 5, I have 5, I ate 3, that means I have 2 left. 8 can be seen as an action word. So I'm gonna go ahead and actually box that word 8. And as I described just now, 8 actually means subtraction. So we're gonna take away something as a snack before cooking it. So here's the part I need to underline. So I want to write an expression that represents the total number of pepperoni slices on the second pizza. So the word total is also important. I'm looking for something that's going to give me the total amount that I have left. Normally when we see total, we'll say it's an addition problem. But sometimes total just means that you will incorporate some sort of bringing together of how much you have all together. So now there's a lot of information that I have here. I know that she has 2 pizzas. I know that on the first, I should have circled first. On the first, if it's a number technically. The first pizza, she had a certain number of pepperoni. We don't know what that is, which is why you leave it P. We know that she put 4 times the amount of pepperoni in the second pizza as she done the first. So she put 4 times the amount. So that's an important information. So 4 times of the first pizza. So we go ahead and circled, we underlined, and we boxed. And then we know that she ate 8 slices. So we're going to take away 8 slices. So we're trying to figure out the total number of pepperoni slices on the second pizza. Well, we know that she already put 4 times the amount of pepperoni slices on the second as she did on the first. So we know we're going to do some multiplication of 4 times something. Well, 4 times what? What am I actually multiplying? Well, we're talking about pepperoni, so I want to go ahead and find how many pepperonis on the first pizza. Do I know? I actually don't. It only tells me I have a certain number. So that's why this is a variable. There's a certain amount of pepperoni pizza on the first pizza. So I don't know what that number is. But what I do know is I'm going to multiply whatever that number of pepperoni on the first pizza is times 4 to figure out how many pepperonis she put on the second pizza. So 4 times whatever the first pizza had on pepperoni. But then I go ahead and I got to subtract somewhere. I got to subtract this 8 because she ate 8 slices, which means what am I going to subtract 8 slices for? If I want to figure out the total number of the pizza, I need to include the fact that she ate 8 slices because that's going to take away from our total. So when I figure out how many pepperoni slices she has on the first and multiply that times 4, that tells me how many she put in the second. And I want to go and subtract that 8 to tell me the total number of pepperoni slices she has on the second. Because if she ate 8, I got to get rid of them. They're not there anymore. They're in her stomach. So I got to represent that action with a mathematical operation. So I represented her eating 8 with subtracting 8. So to go through this again, here's my expression. I want to multiply the amount of pepperoni in the first pizza times 4 to figure out how many pepperoni slices she put on the second pizza. And then I want to subtract the 8 that she ate. That sounds weird. The 8 pepperoni slices that she had already eaten to then give me the total amount of pepperoni slices that she has on the second pizza after she cooked it. So here is the expression I'm looking for. And notice how I got to this is by having numbers and an understanding of the action words that I needed to use. I know that 8 meant subtracting. There's my subtraction. I know that times my multiplication. Here's my multiplication. 4 times P minus 8. So what we're going to be doing here is looking at the process of using our action words to determine what operations need to be in our expression and then figuring out what numbers we need to solve this word problem correctly. Let's try another one. Here's another one. It says Greg has 3 more than twice the number of dollars than his brother Jeff. Write an expression for the amount of money Greg has. So once again, I read it for the first time. I'm going to go ahead and do my annotations. I want to circle any numbers that I see. I want to underline the question. I want to box any action words. So Greg has 3 more. Okay, so here's the number 3. Has 3 more. More is definitely an action word. More than is definitely an action. More than. So 3 More than. When you think about I have more than somebody, what kind of operation? Is that adding, subtracting, multiplying, and dividing? Exactly. If I have more than somebody, I'm going to go ahead and consider that an addition. So however many that person has, I'm going to have more than that person. So if I have $5 more than anybody here, however much money you have, I'm going to have $5 more every single time. So that's an addition phrase, addition action word. More than twice. Ooh. When you see numbers like twice or triple or quadruple, these are always tricky because technically they are a number and they are an action word. I have twice as many Pokemon cards as you. If you have 2, I would have 4. So technically twice tells me that it's 2 times. So I'm gonna have to multiply something times 2. The number of dollars, then his brother Jeff. The number of dollars. The number of dollars. This is a number. Do we know how much money Jeff has? No. But I can represent that as a variable, dollars, to represent how much money Jeff has. So I want to write an expression for the amount of money Greg has. So Greg has 3 more than twice the number of dollars than his brother. So I want to multiply something times 2, and I want to add 3 to something. What am I going to do it to? Well, Greg has 3 more than twice the number of dollars than his brother Jeff. So if D represents the number of dollars that Jeff has, I need to multiply 2 times how many dollars Jeff has. That's just gonna because Greg has twice as much as that. But I'm not done yet because I gotta include this addition operation. So he has 3 more than twice. So I gotta also include that I need to add this 3 to the total to figure out how much money Greg has. I figured out that to multiply, what I need to multiply, I need to multiply the 2 times the number of dollars that Jeff has. But I'm not done there because I also have to add 3 because of this more than to figure out the total amount of money that Greg will have. So to figure out how much money Greg has, I need to multiply Jeff's dollar amount times 2 and then add 3, and that will give me the total amount of money that Greg has. When you do your work today, I'm going to be looking for some specific things. I'm going to be looking for you to annotate. I will go ahead and give you the action words. It is your job to determine what you need to do with those action words. So, for example, when I figured out that more than meant addition, what am I adding? Well, I'm adding 3. What am I adding 3 to? I'm adding 3 to whatever 2 times the amount of dollars that Jeff has. This is how this works. Once you figure out the operation that you need to use in your expression, what 2 numbers do you need to do that? So, for example, I needed to find out what twice the amount of Jeff had in order to add 3 on top of that. But before I can do that, I need to figure out how much money Jeff has so I can multiply it times 2. So the understanding is you need to use your action words to really, really tell you what expressions need to be in or what operations need to be in your expressions. I know I need to have an addition and a multiplication in my expression. I represent that here, 2 times D plus 3. Once you know what operations need to be in an expression, then it's your job to figure out what numbers you need to use for those operations. I need to multiply 2 and D, and I need to add 3 to that total. If you wanted to you could have also written like this, 2 times D plus 3. Same thing. I wanted to multiply first 2 times the amount of money that Jeff had, and I want to add 3 at the end to figure out how much money Greg has. It all works the same way. Hopefully this helped, and we'll see if during your skills practice this gives you a little bit more insight as to how it should work. I'm going to go ahead and highlight in your independent practice the action words. Your job is to continue to circle and underline the question and then create an expression from that. So best of luck, Kipsters, and I will see you later.